that before somebody just gets done saying the blessing and then there's not you up.
Oh.
Okay. Questions for the quiz?
The last one, or the square.
Will it have the square? So the information given was?
It was you have a square and your diagonal is 26 meters squared or whatever.
26.
Yeah.
Was it meters, inches? What was it?
I think it's meters squared.
Meters. Okay, who can do this one?
Bless you.
Okay. So the way I looked at it was I just said, well, we've got two triangles here. Since we know two triangles and it's a right angle because it's a square, so we know the Pythagorean theorem is a squared plus b squared equals c squared. So we can say this is a and this is b, but since this one and this one are the same since it's a square, we can erase that and just make that a as well. So instead of a squared plus b squared, we've got 2 times a squared equals that, so 26 squared. Now I can figure out what 26 squared is. I don't remember what the number is.
We need 26.
That's when you divide it by 2. What's 26?
676.
676 equals a squared. And the area of a square is a squared.
So you've already divided that by 2?
Oh,
by 2?
by 2, sorry. 2. So then a squared equals, if we divide that by 2 and this by 2, then I get 338.
Yep.
Okay. And since we know that the area of a square is a times a, or a squared, we know that's the final answer. And then you put it in, I don't remember, units squared.
Yeah.
Yep.
Okay, so the question asked for what? The area of the square. And that is a squared, right? Or you could have taken the square root of a squared and got square root of 383 or 338, and then what? Times it by itself, that would get back to the 338, right? Anybody have a question for her? Okay. That's the only one that caused any problems, or does anybody else have another question? Let's talk about the follow-up from the pyramid thing that we were doing in class. As you worked on your pyramid, then you went to a spreadsheet. You got those handy there. I'm going to quickly, very quickly, our layers were 1, 2, 3, 4, like this. And I'll just fill this down to, I think we had 10, wasn't it? The pyramid volume was 1, then 1, and over here we went, well, 1 divided by 1, let's go ahead and build us a formula here, equals the pyramid volume divided by the prism volume, right? Okay, and then how did we get this one? This is our 2-layer one. So we've got a 2 by 2, and sitting on it we've got a 1 by 1, right? Everybody see it? So how much? 5, but can we build a formula? Somebody said the other day we can. Equals the base volume, which is the bottom layer, which is simply what? The layer squared, right? Raised to the second power. And then what do we have to add to that bottom layer?
Previous.
The one that was up above it, right? What?
It clicked out of your formula.
What to do sum?
Plus this one. Now click. There, 5. Now let's see if this works. The next one will have 9 on the bottom layer, right? With the 5 we've already got sitting there on top of it. Let's see if we get... Yep. So that should be that. Now this one, what would it be?
The layer.
Volume of the prism. In other words, had the pyramid gone straight up on all sides, what would it have been its volume? So it would be a prism that's 2 by 2 by 2, so it's equal to 2, we could do it this way, times 2 times 2, right? Or we could have done that number cubed. And we fill this down. Then this one becomes what? Well, we already got it, right? Do you have those as your decimals? Now what's fun is to take this and run it down a ways. How far should we go down? 500? All right. The volume of the prism is getting very large, very fast, so large that it's not, there we go, widen the thing and it tells us, takes it out of scientific notation. But what we're interested in is this ratio. Anybody want to make a observation? Maybe this will help. What if we took column A, all of column A, and I'll control-click column D, which means I want to plot, this is my inputs and this is my outputs. And then I will insert let's do a scatter plot that is connected. So the ratio starts out at 1, and quickly drops, and appears to be what?
As the number of layers approaches infinity.
As the number of layers approaches infinity, and stop and look. As the number of layers approaches infinity, our bumpy pyramid, if it had billions of layers, what would it look like?
Line.
It would look rather smooth, right? The more layers we got of it, the smoother it would look. And it appears that our ratio of the pyramid to the prism, does it keep going down, or it looks like it might be approaching a number. That number is what? 1/3? What's the decimal for a third? Let's take this thing down just a bit further and just see how, because we're at 0.33, but where do we get to so that it looks even closer to a third? There's over 1,000. Let's see what that does. Now we're to 3 decimal places, right? And we could continue to go on down, see if we can get it to 4 or 5 decimal places here. We're still at 3, but okay, can everybody see that? What does that mean? Well, it simply means this. I need some help with this. Laura, can you come over here? And I'd do it there, but I don't want to get water in your computer. So, okay, so would you hold that? And let's see, I'm going to. Where are we going to go here? So there we go. All right. So she has a cube, a prism, whose base area is identical, right? Whose height is identical. So, according to the ratio we just got, if I take and pour this pyramid full of water and pour it into the prism, I should get what? It should fill a third of it. Does that look like a third? Let's try it. Let's pour in a second. And a third. And it appears that a pyramid holds volume a third of the prism that would have contained it. That it would have been same base area and same height. Does that make sense? Pour that back in. Okay. Well, if that's true of a square pyramid, it's also true of a that. Here we have a triangular prism and a triangular pyramid. Their base areas are identical and their heights are identical. As we pour, there should be 3 of these. 2 and 3. Whoa! I must have, because where the this little place snaps in, I may have poured it just a bit too full on one. It also works with anything that comes to a point. So not just prisms. Here we have a what? Cylinder and a cone of equal base area, right? Their heights are identical, so how many cones will fit in a cylinder of equal base and height? 3. 2 and 3. Now, has everybody been creating a list of a list of formulas? Have you been, every time we would discover a new one, have you been adding it to your list? Let's add this one. The volume of a pyramid is equal to what? 1/3 of what? The prism that it came from. Well, what's the prism formula? We've got that earlier. Base area, the base area, which for a rectangular one would be length times width, but with a triangular one it would be 1/2 BH, little bh. But whatever the base area is, capital B is, times the height, right? So 1/3 of that will give us our pyramid. Likewise, if we do a cone, it's going to be 1/3 what? Capital BH, right? It's just that the capital B on a cone is what? A circle. So what's the base area of the circle? Pi r squared h, right? This right here is really the B, correct? Okay? But the reason I did this, because we don't know whether this is a square pyramid or a triangular pyramid, but any pyramid is just base area times height, and then we take a third of it. Okay, we all right? Add that to your list of formulas. Questions about pyramids? Would you be able to find the surface area of a pyramid? How would you do it? This particular one here. Make a net. What would the net look like? There would be a square for the base, and then, so if I cut down on each of these lateral edges, we'd have the base here, and then we'd have triangles, whoops, coming out something like this, right? And now all we've got to do is find the area of the square. We know that formula. The area of the triangle, we know that formula. Since they're all the same, we would what? Multiply by 4 and then add it all together. Does that make sense? All right. Let's review cylinder. Cylinder, how do we find the surface area of this? The very same way we do the surface area of everything. Make a net. This net looks like this. I've got a circle on top, a circle on the bottom, and when I unroll this, what do I have? A rectangle. Whose what? Whose dimensions are, this is what? The height of the cylinder. This is what? The circumference of the cylinder. So our net that looks like, we've got a circle here, we've got this rectangle here. And by the way, this doesn't have to be attached on this end. I could attach it on this end as well, right? And fold it down. This is the h, the height of the cylinder, and what is this length? The circumference, which we know is 2 pi r. That was the day we brought our circular objects and discovered that, or you could put pi d, right? We discovered that 3 and a little bit more diameters go around the outside of the circumference. Okay. Do we have a formula for this? We do. It's just like this, except what? The 1/3's not there. Okay? That makes sense? So if you don't have a cylinder volume formula, we need it, and it's just that, right? It's base area times height. Circle, that's how many are on the bottom layer. And the h is how many layers there are. Okay. What we're going to do is we're going to move now to spheres. I need you to get in partners. 2, 2, 2. We're odd numbered today, so you can take your pick.
Us three usually go.
You 3? That means, let's see, wait a second. Wait a second. Did I get? Yeah. Wait a second.
Since you have an odd number here, there's
Oh, odd number, yeah.
and then an odd number.
Oh, so we're so we need.
He just goes with her.
Yeah, there we go. You want to go there?
Sure.
I'm hoping we've got. And how many pairs is that? 1, 2, 3, 13,
14.
14. Maybe we're going to have to. How many do you got? 4. 9. Yeah, we better do threesomes. Threesomes.
So U3.
So U3,
Closer together.
U3, U3, there we go. U3, 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 U3. You go with those two, and then back would be 4, I guess. For somebody here? Yeah. Okay. All right, here we go. Let's see, that's for you're with those two.
You want a manager, please?
Oh, this is not good. All right.
Probably some order.
Okay. Each threesome should have a piece of acetate or transparency strip, a pair of scissors, and a ruler. Okay? So what I want you to do is get your piece of clay into as perfect of a sphere as you can get it. As perfect of a sphere as you can get it. So roll it, knead it, whatever it takes. It should be as close to a perfect sphere as possible. No flat sides, no, just a perfect sphere. As soon as you get it into a perfect sphere, what we need you to do is take your piece of plastic and wrap it around here, and then take a look at. You want to really get it to get this to come out the way we need it to. You need to have a perfect sphere. Wrap your plastic around it, and I want you to look at where the top hits it, and I want you to cut it off so that if this is your sphere, the plastic that you've wrapped around here is this will be touching the center of that circle on the bottom, okay? And you'll have this cylinder, and this point right here, this point on the top of the sphere, if you were to put a card or something over it, it would just barely touch it. So we have the sphere that is inscribed in the cylinder. Okay? So I need this, the height of that cylinder, you need to trim it off with your scissors so that it's exactly the same as the height of your sphere. The diameter of your sphere, you might call it. Okay? Height, trim it off, get yourself a piece of tape, and tape the plastic strip around it. Okay? So that the cylinder is actually taped onto it.